Okay, hi everyone. I'm realizing actually I probably should walk away. Can you hear me if I walk over here and I'm still talking? Yeah, okay, good to know. I have a nice deep voice. Okay, so I wanted to start off by thanking you for having me here today. It has been an interesting experience this afternoon. I don't know how many of you are from places where tornado warnings are frequently affected, but unfortunately we're all here and there's no, doesn't seem to be any buildings flying in the air or anything like that, so it's a good thing. I want to particularly thank Della, who's been a tremendous host, and this is just really a beautiful campus, and I'm really happy that I've had the opportunity to meet many of you already today. What I'm going to talk to you today is some research that tries to identify a potential barrier, often a hidden barrier to women in fields such as math, science, and engineering. And I definitely want to touch base on some research that attempts to identify ways to overcome this barrier. So that really, I want to make that a main focus. I'm going to encourage you to ask questions throughout this talk. I don't know, my impression was that I was going to be talking to people who are math and science majors, but I have a sense that there are a number of, how many of you are psychology majors in the room? Okay, how many of you are majoring in what I will term STEM fields? So I'll use the term STEM. It refers to science, technology, engineering, and mathematics. How many of you would say? There's probably a number that are undecided. Okay, so there are a fair number of you. So I'll just mention that most of what I'm going to present today is termed experimental social psychology research. And what I mean by that is, for the most part, what we do in studies is we will recruit a bunch of participants. We will randomly assign them to conditions. So we'll randomly assign them to either an experimental condition or a control condition. We'll manipulate something in that experimental condition. And then what we're going to look at is a difference in performance between the two conditions, okay? A mean level difference in performance. If at any point this isn't clear, you're unsure about some of the research that I'm presenting, feel free to ask. This is basically how we determine causation, is by doing this type of manipulation, and how we rule out other possible explanations for the findings. So again, if you have any questions about this, please don't hesitate to ask. Okay, and as I just mentioned, occasionally I use the word STEM. I'm referring to people who are in the sciences, technology, engineering, and mathematics. Okay, I'm going to try using this. I don't usually, so we'll see how this goes. Oops, going the wrong direction. Okay, here we go. So when it comes to the representation of women in STEM fields, it will probably come as no surprise to many of you, particularly the faculty members, that women actually tend to be underrepresented in a good number of these fields. So I'm just going to present a couple of statistics that have come from the National Science Foundation as well as the National Center for Education Statistics. According to some statistics, only about 20% of undergraduate and doctoral degrees in fields such as physics and engineering are awarded to women. And according to some statistics, again, only about 10% of the workforce in the physical sciences, math, and engineering is female. Now, I'd like to think that this is actually, these statistics are a little underrepresentative of the actual numbers out there. Depending on what you read, sometimes the numbers seem a little bit higher for women. One paper that I just recently read actually suggested that computer science is one major where women, the proportion of women actually seems to be decreasing in terms of the number of women majoring in computer science, which is surprising given the fact that it's such an important field right now, given all the recent developments in technology. But just to give a more concrete example, when we look at the ratio of men to women at competitive and very reputable small liberal arts colleges, such as the University of Richmond or Washington Lee University, we actually find that these stats are pretty representative. So some of you may see your faces up there, some people in the room. So according to what we looked at, we actually found that about 85% of the faculty at these two institutions is male in the math and computer science departments. And only about 15% is female. Okay, and for those of you who are wondering who those fine women are, here they are. Here are some of them in any case if they provide a picture. And I actually noticed that, I'll try using this pointer way up there, there's a budding potential scientist up there, but she doesn't come quite yet. Which means you put her time in still. Okay, so the existence of a gender gap really tells us nothing about the reason why there's a gap, right? So we can look at all of these statistics and we can say, well, women are underrepresented in this field, but by looking at these stats alone, we really have no idea, what are some of the factors that's leading to this discrepancy? Why isn't it that we're finding, an even split between males and females pursuing these domains? However, I'll just mention that sometimes this discrepancy gets translated into belief that women are innately not as good in these domains. Okay, so sometimes people look at these statistics and take from that the notion that women just don't innately have the same abilities that men do to pursue these different areas of study. And this is well exemplified by fairly recent comments by Lawrence Summers, who was at the time the president of Harvard University. Some of you may have come across this. It's gotten a lot of play. Because he picked a great occasion to share these comments as well. So he was at a conference promoting diversity in the sciences, and at this conference, which was held at Harvard University, I think 5 years ago, this is what he basically had to say. He at least noted that he was being provocative. He said, "So my best guess to provoke you, what's behind all this, is that the largest phenomenon by far is the general clash between people's legitimate family desires and employers' current desire for high power and high intensity. That in the special case of science and engineering, there are issues of intrinsic aptitude, and particularly of variability of aptitude, and that those considerations are reinforced by what are in fact lesser factors involving socialization and continuing discrimination." Now, I'll tell you these comments weren't particularly well received by the audience or by the greater academic community. Okay, so people took issue with the suggestion that issues of intrinsic aptitude are a primary determinant of this gender gap. So Elizabeth Spelke, who's a very prominent developmental psychologist, she's currently on faculty at Harvard, she took a very empirical approach to expressing her dismay. So Liz Spelke has done extensive research with children, examining their innate abilities for mathematical thinking early in life. And within a few months of Lawrence Summers' comments, she had published an article in American Psychologist in which she reviewed the literature on sex differences in math and science aptitude. Based on the review of this literature, she concluded that research on the cognitive abilities of males and females from birth to maturity does not support the claim that men have greater intrinsic aptitude for math and science. Okay, in 2006, Ben Barrs also published a paper in Nature. He published his in Nature. And Ben Barrs is a really interesting case. He was at the time, I think, a neurobiologist at Stanford, I think possibly a physicist. I don't know, he had been in a couple of different departments. But he's a really interesting case study that we can't do, unfortunately, in social psychology. One of the things we love to do is randomly assign you to gender. Make some of you men for a while, see how you do in math and science, then change you back to being a woman. He's actually a transgendered individual. So he actually had the experience of being a woman, majoring in math in a STEM field, and then had a sex change operation and was able to have this experience as a man. So his commentary was both anecdotal as well as empirically driven. Just to provide you with some excerpts from his article, first off, he starts off by pointing to some sexism that he received as a woman at MIT. He said, as an undergraduate at the Massachusetts Institute of Technology, I was the only person in a large class of nearly all men to solve a hard math problem, only to be told by the professor that my boyfriend must have solved it for me. Now, I assume this was a joke that the professor was trying to maybe lighten the air, I don't know. But I don't think it was taken in any, I don't think it's a particularly good joke. I'm sure he didn't appreciate it at the time. Okay, he then goes on to say, I'm still disappointed about a prestigious fellowship competition that I later lost to a male contemporary when I was a PhD student, even though the Harvard dean who had read both applications assured me that my application was much stronger. I had published 6 high-impact papers, whereas my male competitor had published only 1. Okay, so here he's noting some potentially explicit discrimination against him as a woman. This is maybe my favorite. Shortly after I changed sex, I heard a male faculty member was heard to say, Ben Barrs gave a great seminar today, but then his work is much better than his sister's. Okay, same work, same person. Just different sex. So no sister involved, it was just him before he had the operation. Okay, and then finally, after reviewing a fair amount of literature, Ben Barrs comes to the more empirically driven conclusion that despite the powerful social factors that discourage women from studying math and science from a very young age, there's little evidence that gender differences in math abilities exist, are innate, or are even relevant to the lack of advancement of women in science. Okay, so although there's very little evidence that women's intrinsic aptitude is any different to men's, why I present these comments by Lawrence Summers, along with those of Ben Barrs, is to illustrate the threat that can exist in the air in STEM fields for women. And the threat that a woman might be reduced to a negative stereotype in her group about her group, and this is basically what's at the essence of stereotype threat research. So this is what I'm going to talk a little bit more about today, is this notion that being in a situation where you might just be seen through the lens of gender or through the lens of some other group membership can actually impact people's performance. And that's what stereotype threat literature has been demonstrating repeatedly. Okay, so I'll just give you a little roadmap about what I'm going to talk about today. I want to start just by defining stereotype threat and providing you with a brief history on the research findings, including some of the now vast amount of research documenting the situational impact that stereotypes can have on women's performance and orientation towards STEM fields. Next, I want to focus on something that I believe will be of greatest relevance to most of you here, and that is how we can actually try to alter the situational cues to help decrease the probability that people will be affected by stereotype threat processes. Okay, and with that, I will talk both about situational interventions, so things that particularly faculty members, departments, other people in positions of power can do in the situation to actually make it a less threatening environment. And then also I'm going to talk about personal interventions. So what about if you find yourself in a stereotype threatening situation and you're not able to change the situational cues? Are there things that you can do in that situation just to basically eliminate stereotype threat? Okay, and then I'll just conclude. Based on time, we'll see how we're doing, but I'm happy to talk about, particularly in the Q&A, about different things. I've spoken with some of you already about this. Some of my own work on the early emergence of gender stereotypes. So when are these stereotypes even forming? How are we being impacted by them? And also automatic stereotyping and how that might differ from explicitly endorsing stereotypes or believing in different stereotypes. Okay, so I'll just start off by talking about what is stereotype threat. Okay, the theory of stereotype threat was initially put forth by Steele, who's pictured here to the left, and also put forth by Steve Spencer and Josh Aronson, who are pictured up here. I put Tony Schmader here as well because she's done a fair amount of work trying to better understand the underlying process involved with stereotype threat. There are a number of other researchers who are doing stereotype threat related research, myself included, but these are the main people who came up with the theory initially. And the theory of stereotype threat is a fairly simple one. Basically, and I'll just go through a little bit specifically defining what this is. What is stereotype threat? And the definition is basically being at risk of confirming a self-characteristic and negative stereotype about one's group. Okay, and the hypothesis involved with this is that stereotype threat can create a disruptive concern that leads one to inadvertently confirm the stereotype. Okay, so for example, imagine that you are needing to orally defend something that you've done in a STEM field, okay? So maybe you are a master's student and you're defending your thesis, or an undergraduate student who's defending their thesis, and you have maybe the professor that you've worked with in the room, and then you end up with an external examiner. So someone new comes to this setting and comes in and is going to ask you questions about the work that you've done. Imagine that this person is male and you're a woman, because some of you aren't in this room, and you need to actually defend this. You find that the male examiner, this male faculty member, comes in and asks you quite a challenging question. And in that moment, you find yourself, as you're coming up with your answer, facing some challenges. It's not that easy to answer the question. You're not sure if you're going in the right direction in answering it. You find yourself sort of stumbling over what you're saying. And then as you realize you're stumbling over what you're saying, you sort of get the sense that, oh no, he might be seeing me as someone who can't do this. Okay, and he might be seeing that because of my gender. Okay, he might sort of be taking this as evidence that women can't do this. Okay, so these thoughts are very quickly going through your head. Maybe you can't even articulate it, you're just sort of getting this uncomfortable feeling, and you find that your performance actually declines even more. Okay, as this disruptive concern comes into play. That is essentially what stereotype threat is trying to get at, is this notion that you might start to worry about things that you might not otherwise in a stereotype threatening situation, and that might actually decrease your performance. Okay, and just to quote one of the initial articles that put this forth, the existence of such a stereotype means that anything one does or any of one's features that conform to it make the stereotype more plausible as a self-characterization in the eyes of others and perhaps even in one's own eyes. Okay, that was the initial theorizing by Claude Steele and Josh Aronson. Just to provide some more specifics about when and for whom stereotype threat is likely to occur. It's most likely to occur when the task is challenging. Okay, so imagine taking a calculus exam, and as you start into it, you're just flying through it. There's no problems, it's easy, you know it, you do it. Okay, that's not likely to be the case in which stereotype threat is going to be evoked. Because there's no possibility of failure, there's no possibility of not doing well. You're doing it, you know how to do it, it's fine. Imagine another scenario where you sit down to take a challenging math test, a calculus exam, that you feel fairly prepared for, but as you start into it, there are questions that you really don't know, and you're not sure of them, and you find yourself having a hard time calculating it. What you might find that you're doing is checking your work, rechecking it, getting a little bit nervous, you start to feel a little bit stressed, oh no, this is not going well. That's going to be the situation in which stereotype threat processes might kick in. Okay, it's also most likely to occur for students who care very deeply about the domain. If you don't really care about calculus, if you don't really care about performing well in STEM fields, you're not likely to be that affected by stereotype threat, and that might be in part because you don't care that much about the domain, right? You don't really care about your performance in it. Okay, so ironically, this is a process that is really likely to affect the people who are the most likely to go on and be really successful in these domains, and that's why it's such a disconcerting process and why it's being researched so extensively. Okay, just a couple of other notes. So this does not occur because one's internalized the stereotype. Okay, and the example that I want to give of that, the other day I was bringing one of my sons just started into kindergarten, and I was bringing him to the initial orientation. And as I was walking in, there was another little girl who was coming to her initial orientation, and she said to the female teacher, "Do we have to do math in this class?" And the teacher said, "Yeah, sorry, I don't like it either." And I thought to myself, oh no, do I say something in this situation? You know, why are they having this dialogue? But really that's talking about an internalization of the stereotype, okay? So and potentially there could be other reasons for it, but they've sort of accepted they're not math people. She's 4, she's decided she isn't a math person for whatever reason. And so that's a situation in which stereotype threat's not going to occur, it's being internalized, okay? They're not identified with the domain. And also it's really important to note that this is what I'm talking about today is a situation-specific threat. So this is something that's going to happen in one context, but won't necessarily happen in another context. If we can lift that threat out of the context, and I'll talk about some of the ways how, really it's not going to be a problem. Okay, so this isn't talking about long-term socialization, it's a situation-specific threat. Okay? One other quote for clarification. Ironically, their susceptibility to this threat derives not from internalized doubts about their ability, e.g. the internalization of the stereotype, but from their identification with the domain and the resulting concern they have about being stereotyped in it. Okay, now it's also important to distinguish this from other factors that have been shown to contribute to the gender gap in STEM fields. Okay, as suggested by the previous quote by Ben Bars, there do continue to be some forms of discrimination that take place in this field, usually based on gender stereotypes, but because of that, it can contribute to the gender gap. So for example, you know, in some contexts, people might receive overtly sexist comments directed at them, which is essentially a form of discrimination. Ben Bars mentioned the possibility that he didn't receive a fellowship because he was female. In 1999, the MIT, Massachusetts Institute of Technology, the female faculty actually put forth a report that basically documented systematic discrimination that had gone on directed at them. They found that female faculty had not received the same amount of pay, research space, or startup funds relative to their male counterparts. Okay, so discrimination does continue to be a problem. Oftentimes it's unintended discrimination. So people might not know, you know, maybe the women are negotiating for their startup packages and you know, it's sort of not known that maybe they're not getting as much as their male counterparts. But simultaneously, if this is systematic, then it's an issue and can contribute to the gender gap. Okay. Gender socialization processes. So again, over the long term, stereotypes can impact people because some people can be socialized to just not believe that they're able to do certain things because of their group membership. Again, this is not what Stereotype Threat is touching on, but this is a factor that can contribute to the gender gap. And then also concerns around work-family conflict. So Stephen C.C. of Cornell recently wrote a review paper in which he basically said, you know, women might be leaving these fields to some extent in order to have more opportunity to balance work and family. So this has been documented as a bit of a factor influencing this gap. I would argue in some cases, you know, programs could be structured slightly differently so that this is less of a factor. If some of these fields were a little bit more welcoming to women in terms of their ability to balance these two things, this might not be a factor any longer. So, but this has been documented to be one of the reasons that might contribute to this gap. Okay, basically what the stereotype threat literature is suggesting is that even if we can eliminate these factors, even if we can have something in place so that there can't be systematic discrimination, maybe there's a standard startup package that goes to incoming faculty members, for example. Even if we take people who, you know, have been socialized in a way that completely, you know, gets rid of this possibility of gender socialization, they're encouraged in math and science from a very young age. And even if we deal with concerns around work-family conflict, so even if people are in specific situations where it's really not an issue for them, they've found ways to deal with it, they may have additional supports, they may have the financial opportunity to get supports in place. Even if we get rid of all those things, the possibility exists that that threat might still stay in the air. Okay? So that's what I want to talk about today, and presented through this research is how we've documented stereotype threat effects, with a particular focus on how we might eliminate some of these effects. Okay, so what research has been done to show that stereotype threat is a real threat to women in STEM fields? Well, I'll just give you a few examples of ways that this has been studied. This is the initial study that was done to document stereotype threat effects, and so I'll just talk you through this a little bit. So again, this is an experimental design. What we do is we recruit math-identified women. This is research by Steve Spencer and some of his colleagues. Recruit math-identified women and men, and we'll ask them to take a very challenging math test. Okay, so again, we're getting people who are highly identified, and we're putting them in a challenging situation. And in a condition for this particular study, participants were told, actually initially, they were told in both conditions, as you may know, there's been some controversy about whether there are gender differences in math ability. Previous research has sometimes shown gender differences and sometimes shown no gender differences. Yet little of this research is being carried out with women and men who are very good at math. You were selected for this experiment because of your strong background in mathematics. Okay, now again, we're going to randomly assign people to conditions. In one condition, the experimental condition, the instructions went on to say, you know, we've already been pilot testing this math test, and we found that there are actually gender differences on this math test. Okay, in a control condition, participants went on to read, we piloted this math test, and really there are no gender differences on it. Okay, and then participants were asked to take this very challenging math test and look at their math test performance. And what we can see here is that when the test is described as showing no gender differences, what we find is that men and women's test performance is pretty much identical. Okay, women and men are performing identically on this test. When people have previously read that previous iterations of this math test have shown gender differences, what we see now over here is that women are underperforming relative to men and relative to women in a no gender differences condition. Okay, so this is one of the initial studies showing that basically a subtle, a fairly small situational change, describing the test slightly differently, is actually having an important influence on math test performance. Okay, now this isn't the best test of this, because basically this might have been a bit of a motivational issue, okay? So women might have come in, they might have said, why are you giving me this test that's showing gender differences? You know, I'm not going to try as hard on it. It would be nice to think that that was the case, and that in most real testing situations, this just wouldn't be an issue. But we've now replicated this type of effect with all sorts of different manipulations. So I'll tell you a couple of them. For example, changing the gender composition of the testing environment has been shown by some researchers to affect the math test performance of women. So women and men in the study completed a challenging math test in either a same-sex or a mixed-sex testing environment. So there were 3 people in the room, I believe, and so they altered whether or not it was all women or whether or not they were in there with men. And what they found in this particular study was that once again, here's women's test performance. When they're taking the test with other women in the room, they're performing significantly better than when they're taking the test in the minority with men in the room. Okay, so just changing the composition of the room is actually impacting their performance. And as you can see over here for men, this is men's test performance, it's really having no impact. Okay, suggesting this really has something to do with the stereotype, not any other distracting factors. And they actually found that when they gave them a challenging verbal task, women's performance wasn't impacted by the gender composition of the room. So this does really seem to be something having to do with math test performance specifically. Okay, is everyone with me so far? So there are a number of other ways that we've done things to basically activate stereotype threat. Again, these are primarily done in laboratories, in testing situations. In fabricated testing situations. So in some of my own work, as well as some work that's been done by my previous supervisor, we found that reminding people subtly of their gender identity. So Margaret, she actually did some work where she recruited Asian American women. Asian American women have a positive stereotype about their racial identity. So there's sort of a positive stereotype out there that Asian Americans are quite good at math. Negative stereotype about women in mathematics. And what she found was that when Asian American women were subtly reminded of their Asian identity, they actually performed better on a math test. When they were subtly reminded of their gender identity prior to this challenging math test, they actually underperformed. And in some of my own work, we found that subliminally priming people with gender can actually impact math test performance. So this is where we'll actually flash words on a computer screen. I was describing this to some of you earlier. We flash words at a speed that's basically slow enough that your brain will automatically read it and process it, but fast enough when we mask it that you're not consciously aware that you're even doing it. Okay, believe it or not, we can do this. It does seem to work. And this does actually have an impact on math test performance. So if I flash you with female-related words, if I flash women with female-related words, we actually find that they subsequently have a drop in their math test performance, okay, relative to if we prime them with neutral words. And this is one other that I just want to tell you about really quickly, because it relates to the comments that Summers made. Reading that the gender gap is due to genetic factors can also impact people's performance. Okay, and I'll tell you in more detail about this study. It was published in Science. And what they did in this study was they recruited math-identified women, and they had a GRE format to this, okay? So they brought women in and they said, you're going to take sort of a GRE test, and the format this is going to take is we're going to give you a math test from the GRE, then a verbal test, then another math test. Okay, that verbal test actually contained a manipulation, and it was one of 4 manipulations. In a no differences condition, basically this verbal test was a reading comprehension test. So they had to read something and then answer some questions about it. In a no differences condition, in math performance, they read something that said, you know what, there's actually no differences in math performance between men and women. They seem to be performing comparably. Okay, so the article was all about that. In a stereotype threat condition, they just reminded people of their gender, so it was an article that related to gender, but didn't actually explicitly mention the stereotype in math. In a genetic differences condition, they read an article that said the sex differences in math performance were due to genetic sex differences. Okay, so something that's not controllable. And then in a final condition, they read about an article that claimed that sex differences were due to specific experiences that women and men have had. So this is something that seems controllable, right? It might be, on average, women and men have had different experiences, and you as an individual might think, well, this isn't really, doesn't pertain to me, so it might afford you some protection from the stereotype in that situation. And that's basically what they hypothesized, that essentially in this experience condition, or in this no differences condition, performance of women on this challenging math test would be much better than in these other 2 conditions. And having the pre-math test and the post-math test allowed them to control for previous ability or previous performance. And they found support for this. I'll just show you their graph and walk you through it. Basically, as you can see, this is sort of a typical stereotype threat effect. When participants had read there were no differences on the math test, we see better performance than when they read, when they were just reminded of their gender identity. Okay, these are all women in this study. But as you can see, when women read that sex differences in math performance might actually be due to genetic differences between the sexes, they underperformed relative to when they read that this might be due to different experiences. Okay, so this seemingly small manipulation is actually having an important effect on their performance, and this was again replicated. Okay, so they did it across 2 different studies. Okay, so this really underscores the power of comments like Lawrence Summers to impact people, right? Because this is sort of suggesting, well, you know, no matter how hard you try, women just aren't going to be able to compete with men. Okay, and I'll just note quickly that this isn't necessarily due to a history of discrimination. They've actually found that white men will underperform if you subtly remind them of the fact that there's a race-related stereotype that Asian Americans do quite well in mathematics, okay? So then you actually see a dip in the math test performance of white men. Okay, and this is also being shown, I'll just note, with a whole host of different groups. I'm just presenting the work in women in mathematics, but there are a whole bunch of different groups that can be negatively stereotyped, and we can sort of get stereotype threat effects on different performance measures. Okay, one other point that I want to make is that women's orientation towards math, so how interested are you in pursuing a career in mathematics or in a STEM field, can also be impacted by these types of subtle cues. So watching an advertisement that depicted an unintelligent woman decreased women's expressed desire in pursuing STEM majors. And in some of my own work, we've actually found that reminding women of their gender through either a brief questionnaire or by priming gender, this pre-consciously, that I mentioned earlier, it also decreased women's expressed interest in math versus arts types of activities, so solving calculus problems versus writing an essay. Okay, so it decreased their relative interest in each of those. Okay, so that's sort of the bad news part of my talk. That these subtle cues can actually impact performance. The good news part of my talk is that there are things that can be done to change the impact that these cues can have. So I want to talk really quickly about those. And that's what I'm going to focus on for the rest of the talk. So I'll just start by sort of suggesting that context can be changed to decrease the threat that's in the air, or that can be when people are negatively stereotyped. Okay, in a chapter that I wrote about on this topic, I suggested 2 very unpractical ways that we can actually get rid of the stereotype threat effects. One is to never be challenged. Okay, as I mentioned earlier, one of the ways, one of the conditions for stereotype threat effects to come about is when we face a challenge. Now, I would ask you to, talk to any of your professors, find out if any of them have faced any challenges in their career, and I'm sure male, female, whatever their background, everyone has faced challenges. Probably at this point in your own academic careers, you've faced challenges. It's not an optimal strategy, and almost suggests that you sort of have to not work as hard, not aspire to as much, and not aspire to be as good as you can be in that situation. So it's not ideal. Also, dispelling the stereotype. If there was no stereotype, there can't be any stereotype threat. And I would argue that we're almost there with respect to dispelling the stereotype. It's starting to happen. And what I'll provide as evidence of this is a meta-analysis by Janet Hodge. Basically, she's conducted some work, a meta-analysis. She collected standardized test scores from all sorts of different states, I can't remember the exact ones, and analyzed these data. And what she found was that effect sizes, differences representing the testing over 7 million students in state assessments are uniformly less than 0.1, representing trivial differences. Of these effect sizes, 21 were positive, indicating better performance by males, 36 were negative, indicating better performance by females, and 9 were exactly 0. Okay, so essentially what that's saying is the math test performance differences between males and females is pretty much disappearing, at least in up to university or college level. She also goes on to point out that in contrast to earlier findings, these very current data provide no evidence of a gender difference in math performance favoring males emerging in the high school years. So this used to sort of be an established thing, in the high school years men start to outperform women. That's no longer the case. In another paper, she finds that gender equity in school enrollment, women's share of research jobs, and women's parliamentary representation are the most powerful predictors of cross-national variability in gender gaps in math. Okay, so this really points to very social factors that seem to relate to the gender gap that exists. So the more women are represented in high-level positions in a given society looking across the world, the less of a gender gap there is in math performance. Okay, so we're almost there, but not quite there. So there are other things that we definitely need to put in place. One of the main ones being enhancing feelings of belongingness. Okay, so that's one of the things that sort of needs to happen in contexts where people are negatively stereotyped. And there are a couple of different ways that we can go about doing this. One of the ways that's being proposed is making sure that we have optimistic teacher-student relationships. I'll talk a little bit more about what that means. And another way is making sure that there are role models in place. That seems to be such a critical piece to all of this. Okay, optimistic student-teacher relationships. Steele writes a little bit about this. Most of this research has been done actually looking at the identification of minority students in particularly academically disadvantaged contexts. Okay, so a lot of this work is not coming out of women in math research, but more specifically focusing on specifically African American students who are coming from academically disadvantaged environments. And yet it seems likely that applying this to women in math is also going to be beneficial. Things like explicitly disavowing the stereotype. So a mentoring context in which male mentors are there, really just making it clear that the stereotypes aren't applying in that situation, that they're not going to see you through the lens of gender is really important. Emphasizing challenge over remediation. Again, because of the context in which this research is coming out of, just if there are contexts in which people are not quite as skilled as others, just making sure that things that are presented, extra work that you might have to do, are presented as a challenge. This is an extra challenge to build your skill set as opposed to it being some type of remediation because you're not as good. Okay, and emphasizing the malleability of abilities. Okay, so realizing that the harder you work, the stronger you're going to get at this. Okay, that this isn't either you have it or you don't, but this is a situation where you build on your skill set. So it's a skill set that needs to be developed. Okay, those are things that need to sort of be coming from the teacher aspect, and I put that out to you both for the faculty members in the room, but also from the perspective of many of you who may end up being in some type of educating position, that's really important. There's also quite a bit of research suggesting that role models are critical in these fields. So some of the research has noted that female role models in mathematics can inspire better performance. Okay, so one study actually had an experimenter who made it clear that she was quite skilled in math, had another experimenter, a female experimenter, who made it quite clear she was not very skilled in math, and not too surprisingly from my perspective, given all this literature, there was actually some indication that women were performed better in the situation where they had a role model. But there's also some indication that even reading about female role models in other domains. So in one study, they actually, I think I've got a slide on this, they actually had women and men either read about a successful corporation and then take a challenging math test, or a successful woman who had overcome difficult circumstances. And what they found was that women and men's test performance was comparable when women had just read about a successful woman, but women were underperforming relative to men on this challenging math test when they had just read about successful corporations. So again, pointing to the power of role models that should really have a positive impact. Okay, in terms of personal interventions, you're not always going to be able to change your context. You might find yourself in stereotype threatening situations that you're not able to control or change. Are there things that you can do so that you're not affected by the stereotypes, so that they're not bothering you or disrupting your ability to perform? Okay, again, much of this experimental work, much of the experimental work has really introduced interventions in a way that we don't know for sure that you can elicit this, that you can actually do this. Sometimes we just sort of do an intervention to people, and we don't know that it's something that you can actually use. But there is some work coming out indicating that there are some tactics that can be used. I can talk a little bit more about that in the Q&A period if you have interest. Self-affirmation seems to be one big one. Okay, so I'll just talk a little bit more about what self-affirmation means. Again, some of this work initially was done with African American students, reducing the racial achievement gap. In one study by Cohen and Garcia. This is basically, this notion of self-affirmation is based on the notion that we have a fundamental need to see ourselves in a positive light. Okay, and stereotype threat can actually sort of threaten that orientation. And self-affirmation interventions are designed to increase people's psychological resources for coping with threat. So basically what a self-affirmation intervention is encouraging people to think about the importance of personal values, so religion or relationships with a friend, and that role in a person's life. So I sort of think of this as the I'm a good mom intervention, that sometimes when I've had a bad day at work, I go home and I say, I've got 3 lovely little boys. Hopefully they're being lovely at that moment. I say, I've got a wonderful husband. I love my life. It's good. It's okay that those bad things are happening at work. Okay, so it's sort of this reaching out and thinking about other aspects of your life that sort of give you peace and happiness, and that sort of refuels you to be able to deal with threatening situations. Okay, and this approach was recently tried by University of Waterloo researchers. They actually haven't written this up yet. They're sort of in the process. But I was assured that this seems to be working with, University of Waterloo in Canada is sort of our equivalent of MIT, probably not quite as competitive, but that's where we have sort of our top engineering students in Canada. And so they've been interested in doing some type of intervention with those students. They actually introduced, I think for first year engineering students, they introduced a 1-hour intervention. So they brought them into the lab, and they either did a self-affirmation intervention where they watched a video about an upper year student just basically saying, saying at times, I get sort of stressed with school, but then at those times I just think about the good friendships that I have, and that makes me feel much better. Okay, and they actually have the students write about this as well, so writing about different values that they might have that they might be able to use to self-affirm. They also did a belongingness manipulation, where they had people write about how everyone has belongingness concerns sometimes. So, everyone is starting out at university, sometimes you're looking to fit in, sometimes you're not sure how things are going. That's a pretty common thing. So they watched an upper year student talk about how they didn't really fit in at first in engineering, but that by their final year they actually felt pretty good about fitting into engineering, to the engineering program. And what they've found so far, and then they had a control condition where they just taught them some study techniques, basically. What they found so far, so this is sort of hot off the presses, is that self-affirmation and belongingness interventions led to higher grades among female engineering students relative to a control group. So they've actually followed these students for 3 years, and they found that those people who were trained, who had this 1-hour training session, have actually done better. Their grades have been better in engineering. And again, we're randomly assigning them to conditions, so presumably these effects are due to the intervention. Okay, I'll just mention really quickly, and I can talk more about this if any of you are interested in it. There are a number of other ways that we found. Again, these are interventions that we haven't really used in terms of you actually being able to use them. So I'll just mention we've done things to people in the lab, such as activating positively stereotyped identities. So I can't guarantee that you can use these in these situations, but you can try. I have some theorizing to suggest that reconstructing the stereotype might actually provide a buffer from stereotype threat. But again, it's not necessarily an optimal strategy. And there's some indication that identity bifurcation might be something that people do. That's basically something put forth by Emily Cronin, who's at Princeton. She's basically suggested that women in STEM fields might distance themselves from certain things, like maybe wearing makeup as one example, that might be associated with gender stereotype, the negative stereotype in fields, and for that reason that might help them to sort of overcome. As we get to the Q&A, I'm also happy for any other strategies that people might want to suggest or things that they think they utilize to cope in any of these situations. But these are some of the things that we've looked at so far, and I can talk about a few others if you're interested, because I think that's the most relevant. Okay, so I'm just going to conclude. My conclusions are basically that stereotypes present a real yet sometimes hidden barrier to women's advancement in STEM fields. I sort of started this talk by saying, what are the implications for both women and men in STEM fields? I think really what this research points to is the fact that, we've come a long way. Women are beginning to be much more represented in a wide range of domains, including things like law and medicine. Apparently, women are entering those programs at near equal levels. But in STEM fields, they're still quite underrepresented. So there's clearly things that we need to be doing to get the optimal performance out of everyone. And I think that both men and women are an integral part of that, okay? So creating safe, positive work environments is one of the critical pieces to all of this. Okay, so basically, although times are changing, more can still be done. I just wanted to leave you with a quote that I found particularly powerful, a powerful explanation for why understanding these processes is important. This came from Sadker and Sadker, who wrote a book titled Failing at Fairness. They basically say, if the cure for cancer is forming in the mind of one of our daughters, it's less likely to become a reality than if it's forming in the minds of one of our sons. Until this changes, everybody loses. Okay? So that's it.